Welcome. This is the Cisco CCNA ENSA, also known as the Enterprise Networking Security and Automation course. This course focuses on the CCNA version 7 curriculum. This is course 3 of 3. So we ended up replacing a lot of these with more modern day connectivities. And that's going to be things like fiber optic, is one of the big ones. Because essentially now we may have our different clients connect either through coax, through phone, through fiber, through wireless, cellular, satellite. It doesn't matter anymore. Our internet will take all of the connectivity types and allow across the board connectivity. So our modern WAN connectivity are broken into 3 main categories: dedicated, switch, or internet. If we're talking internet, that's normally some form of broadband VPN. If we are talking wired, that's going to be like DSL, cable, fiber to home, fiber to business. If we're talking broadband VPN, but we're talking wireless, it could be like a WiMAX, cellular, LTE or 5G, satellite-based internet, or some type of MAN-type Wi-Fi. If those are not what the individual is looking for, maybe they want some form of dedicated connectivity, that'd be like a dark fiber. If that doesn't quite work, then we have a switched network design, and that's going to be packet switching, and that'll either be Ethernet, Metro Ethernet, or MPLS. These are all different types of modern day WAN connectivity that allows for our connectivity. Dark fiber is easily going to be one of the growing areas, and that can be purchased or leased from different suppliers, and essentially it's just long distance fiber. So we talked about our Ethernet WANs, Metro Ethernet, MPLS, but we also have things like VPN or virtual private LAN services, VPLSs. So all of these provide different forms of connectivity, and the benefits of these are going to be reduced expense and administration, easy integration to existing networks because it's all Ethernet based, and it does allow for enhanced business productivity. It's cheaper, essentially. With MPLS, that's multi-protocol label switching, and basically this is high performance switching by our service providers. So the service provider WAN routing technology will interconnect clients regardless of their access method or payload. MPLS will actually I'm going to grab my pen. So you'll see here CE and PE. Client's edge, provider's edge. So it doesn't matter how you connect to the provider. Internally to the provider, it's normally some form of MPLS type internal cloud. Our MPLS cloud from the service provider will take all types of encapsulation from the inside, and it will handle its routing internally to the MPLS cloud. So here's an MPLS cloud. Here's our internet cloud. And the MPLS router will basically label switch routers using LSRs. They attach a label to packets that are then used by other MPLS routers to forward traffic. And this is done fast. MPLS normally is classified as a layer 2 technology dealing with layer 2 switching. That's why it will be high performance switching using labels. So we have a few other types of WAN connectivity, and that's going to be internet-based connectivities. And you're going to notice we kind of already talked about this with modern day tech. However, it can also be its own category using VPN technologies. Again, wired is DSL, cable, that'd be copper coax or some form of fiber optic. Our wireless is some form of WiMAX, satellite, cellular being like LTE or 5G, and some type of MAN-based Wi-Fi. Our DSL technology normally is called, DSL is a digital subscriber line. It's a high-speed, always-on, and normally will use a form of DSL. A common form of DSL is ADSL, or asymmetric DSL. Though DSL does come in other flavors, so we can have SDSL also. ADSL provides higher downstream, and it doesn't provide the best upload, but it can. SDSL provides the same capacity in both directions, up and down. ADSL, they shrink the downstream so you can have more, they shrink the upload so you can have more downstream. Again, that's for ADSL. If we're talking SDSL, our up and down would be identical. So how does DSL work? Essentially, DSL will connect through phone lines, and you will have a DSL modem, and you'll have a phone line back to your central office. This is known as the last mile. My writing with my mouse kind of sucks. Last mile. Through phone line. Once it gets to the central office, there's what's called a DSLAM, or DSL amplitude modulation, and it will modulate the signals to go out either the PSTN network or to the internet. And normally, at this point, when it's going back to the internet, the CO is connected to some form of high-speed backbone to get faster connectivity. DSL is not a shared medium. Each user will have its own separate direct connection between the DSL modem and the DSLAM. So this is one connection. So if there are 25 houses in a neighborhood, there needs to be at least 25 connections on the DSLAM. Older DSL used the PPP, or point-to-point protocol. Now it may be the point-to-point over Ethernet protocol, and it did require DSL to have a sign-on packet. So PPP was used to authenticate the subscribers using DSL. PPP was also used to assign addresses to the subscriber. There are two types of PPP over Ethernet. That is host-based or router-based. So if you had a router, the router would authenticate, and the router would be allowed on the internet. That means anything behind the router would be allowed connection. With host-based, each host had to authenticate to be allowed on the internet. Old technology that is still in existence but definitely is dying. Cable technology is probably by far a little bit better and is definitely growing. Cable will use a cable modem. It will use coax line back to a junction box in your neighborhood. This again is called the last mile. The junction box will change from coax to optical. The junction box will send an optical signal back to the cable's quarters. So sometimes the coax will also be terminated into what's called a CMTS. That's a cable modem termination system, and that's normally located at some form of head office. The fiber medium enables the signal to travel over greater distances, long distances, because coax is not made to travel that far. The head-end container will have the database needed to provide internet access, while the CMTS is responsible for the communication aspect back to the cable modems. And we also have our fiber to home options. So some of those fiber to home options are things like fiber to home, fiber to building, fiber to the neighborhood. Fiber to the facility is definitely growing a lot faster. More build-outs are starting to use the fiber to the curb or fiber to home type build-outs. They may also do fiber to the curb and then do a curb to the inside house using coax, and sometimes those are still classified as fiber to the node or fiber to the neighborhood. Other forms of our internet-based connectivity are, again, municipal wireless, again man-based wireless, cellular using 3G, 4G, 5G, LTE, other broadband cellular technology. We have our satellite, we also have our WiMAX. Again, WiMAX is going to be using our 802.16, that's high-speed broadband using wireless signals. All of this helps to build our VPN-based technologies. VPNs provide cost savings, security, scalability, and is pretty much compliant with any layer 2 or layer 1 based technology. Two main types of VPNs, site-to-site and remote access. Site-to-site allows us to set up a virtual tunnel between two devices through the internet and encrypting the data flow between those two devices. A remote access typically allows like a roaming user to connect to a static location, even though the mobile user's address may be changing. They will still encrypt data flow between the remote person and the static address. Our ISP connectivity, we've looked at this before. Single home, dual home, multi-home, dual multi-home. Our basic single home is point-to-point connection between our business, our home, and one ISP. We could have two connections between us and our ISP. We could have one connection between our ISP and we could have a backup ISP, or we could have two links to an ISP and two links to a backup ISP. It really just depends on how resilient you want to be and how much you're willing to pay. So earlier I kept saying the word broadband. Broadband actually is a massive solution that looks at both cable and DSL. So when we're talking broadband, we need to be able to compare some of our options. So some of our options when looking at our broadband technology are things like cable is going to be using coax and it's a shared medium. Oftentimes the cable provider does oversubscription. Basically, they put more people on the cable than it's made to handle, assuming that not everyone will be using their entire service all of the time. They over allocate. DSL, limited bandwidth, limited distance, and typically is slower. Fiber to the home requires fiber installation, and that's becoming more common. Cellular or mobile broadband is based off of cellular signal. If you're in an area that has poor cellular reception, that won't work for you. Our man-based Wi-Fi, you're kind of stuck where there is some form of metro wireless or some form of WiMAX that's been deployed in your area. It really just depends on what's available. Satellite is the expensive option, but it also provides limited capacity per subscribers. This normally only is happening when this is the only option. I don't believe that this is the lab title for this lab, but we do have a lab investigating broadband and looking at broadband options. And that is it for this module. If you got any questions or concerns, please reach out. Thank you.